Hi everyone, today we're looking at solving linear equations. Now you might wonder about these drawings at the top of the page. I've drawn some of those old-fashioned scales. So you might have a weight in this side and a weight in that side and they balance. Now at the moment this side holds a much heavier weight. So the scales have fallen down this way. The point of equation solving is to have this situation where each side is equal. So you could put an equal sign up here. Our first equation today is x plus 2 equals 5, and I'm going to show you how that represents on the scales. So we have x plus 2 on one side of our scales, and we have 5 on the other side. So think of that as x is a weight, and we don't know how heavy it is. We've also got 2 kilograms in there of something else. In this side we've got 5 kilograms and it's holding balanced. The scales are balanced, the equation is equal, it is balanced. We may want to find out how heavy the x is, and the easiest way to do that is just to take 2 kilograms out of each side of the scales. If we take 2 kilograms out of this side, we'll just be left with that weight. So they'll be gone. On this side, if we take 2 out, we're going to have 3 kilograms. Now I'll show you how that works in terms of the equation. So in this equation, our aim is to find out what x equals. So our last line is going to say x equals something. We have a plus 2 here, and the way to balance out a plus 2 is to minus 2. You do what we call the inverse operation. The inverse of adding is subtracting. So if we minus 2 from this side of the equation, and then to keep the scales balanced, we also minus 2 from this side of the equation. So on the left side, we get left with just the x, and on the right side, we get 3. Let's see that in, oh my goodness, my numbering is wrong. This is number 2, it says 4. So on this one, the opposite of minus 3 is to add 3. So we add 3. To keep our scales balanced, we add 3 over here. So this becomes, this side, the minus 3 and the plus 3 make 0, they're gone. We still have a y. On the other side, 7 plus 3 is 10. This next question, we have 2 times p equals 8. The opposite of multiplying we know is dividing. What we want to do is halve each side of our scales. We want to halve what's in this side. We have 2 p's in that side, and we're going to halve what's in that side as well. So on this side, 2p divided by p is just p. 8 divided by 2 equals 4. So p is 4. For any of these, we could actually check our answer back in the original question. If you put 3 back in here, 3 plus 2 equals 5, that is true. You put 10 back in here, 10 minus 3 equals 7, that is true. Put 4 back in here, 2 times 4 equals 8, also true. Let's try a few more. So number 4, 5, 6. On this one, we have m divided by 4 equals 3. Now the way to balance this out is this is divide, so we want to multiply. Now I tend to write my multiplications up the top in front. If I write a 4 in front of the m, that's like 4 times m. If I times this side by 4, I also have to times this side by 4. So we now have 4m over 4, the 4's cancel, so we get m. 3 times 4 is 12. Okay, now we have what we call a two-step equation. So we need to do, because we're doing inverse operations, we go backwards on order of operations. First we get rid of the minus 1, then we get rid of the times 2 by doing the inverse. So the opposite of minus 1 is plus 1. If we plus 1 there, we must do it here. So from that, the 2f is still there. The plus 1 got rid of the minus 1. 5 plus 1 is 6. And now we have to do a second step to get rid of the 2. Now this is just like we had in number 3. We divide each side by 2. The 2's cancel. We're just left with f. equals 3. Checking that one back in the original, 2 times 3 is 6, minus 1 equals 5. Another two-step, start by adding the 4 on each side. The minus 4 and the plus 4 are gone. The g minus 2 over 2 is still there. On this side, negative 3 plus 4 equals 1. Back to the same thing as we had up here in number 4. So we times by 2 to get rid of that one. If we times that side by 2, this side gets multiplied by 2 as well. G equals 2. Okay, we've got a few types now where we have some brackets. It's really good to look at number 7 and 8 together because they're essentially the same equation, just this one equals 8 and this one equals 9. On the first one, my first step would be to divide each side by 2. Those 2's cancel. We're just left with h minus 3 equals 8 divided by 2, which is 4. And then just add the 3. So we get h equals 7. Now on this one, I wouldn't do it the same way because if you try and divide each side by 2, we're going to get 4.5 over here, and that's not as easy. So instead we go back to what we learnt last lesson about expanding brackets. We have 2 times h and 2 times minus 3. So 2 times h is 2h, 2 times minus 3 is minus 6, equals 9. We add the 6 each side, 2h equals 15, and we divide by the 2. Don't forget to pause and rewind if you need to see this a bit slower. Now 15 divided by 2, you can leave that as 15 over 2, that's okay, or you can change it to 7.5 or 7.5. Okay, in this last one, this line here, it's got a vinculum. It works like brackets. So this j plus 4 is essentially in brackets. We want to get rid of the 3 first and leave the brackets till last. So let's multiply by 3 to get rid of that 3. Multiply that side by 3. Those 3's cancel. We've got j plus 4 equals 6, minus the 4 from each side, j equals 2. So the questions you need to do from those 2 exercises are listed there. I will also put a photo of this page onto Canvas.